Okay, this video will be part 2 of lesson 4. So part 1 of lesson 4, the entire 30-minute video was essentially on 3 special triangles, that 45, 45, 90 and the 30, 60, 90 special triangle. And can you draw those special triangles? And from those special triangles, can you fill in this chart? Okay, so that is something that you just need to know inside and out. And what I will do is part 2, it's going to show you now, we haven't even done any class examples. So part 2 is going to be going through the class examples, and you need to be able to understand those special triangles or you can't do any of these class examples. Okay, so again, just make sure you are, before you follow along with this video, that you understand those special triangles, and then I'll show you how we're going to apply them with these examples. So class example 1 is on page 169 of your workbook, and what it says is it gives us a sine of 210 degrees, and it says, what would this angle be as an exact value? So again, if this was a quiz or a exam, you're always going to highlight, underline that word exact value, and that means no decimals. So that's the first thing you have to understand, no decimals. And that word exact value, that's going to be your clue. You're going to need special triangles. So again, if we were in 10C and I said, well, what's the sine of 210 degrees? It'd be the easiest question ever, because you would just say the sine of 210 degrees and there's your answer. We can't do that in 20-1 or 30-1. We have to do so much work to actually get that answer. So how do we figure this out? First thing that you need to do is we're always going to figure out what the reference angle will be. This all has to do with the reference angle, because once you know what the reference angle is, from there, you're going to get your special triangles. Okay, so how do we figure out the reference angle? Sine of 210 degrees. Let's take our Cartesian plane. So everybody draw yourself a Cartesian plane, and let's put where 210 degrees is. So remember that we go from 0 to 90 to 180, down here is 270, and one complete rotation would be 360 degrees. So 210 degrees would be from 0 to 180 and slightly past 180. That would be 210 degrees. Okay, so your first step is you always draw the angle, the rotational angle that they give you. So there's 210 degrees. Then from lesson 3, what do we always do once we drew our rotational angle? We always drew our acute triangle, right? So from here, let's draw our triangle. So put a point on your terminal arm, and that point, a vertical line to your x-axis. This would be our acute triangle. And from this acute triangle, I could get this angle here, which is my reference angle. So how do you get that angle there? And what I'm going to do is I just have to clean this up a little bit. How do you figure out what that acute angle is? Using 180 degrees and 210 degrees. How would you figure out what this little blue angle is? And I'm hoping that you would see that that's how you would calculate your reference angle. And you would take 210 degrees and you would subtract 180 degrees. And theta r, which is my reference angle, would be 210 minus 180, and you should get 30 degrees. And you guys, if you think about it, that should make sense, right? Because if you go from 0 to 180, plus an additional 30, so 180 plus 30 would give you that rotational angle of 210 degrees. So now that we have a reference angle of 30 degrees, you need to do your special triangles. So what special triangle was our 30-degree special triangle? That special triangle was the 30, 60, 90-degree special triangle. And remember that the 30, 60, 90 degree special triangle, I said to memorize the numbers 1, 2, root 3. Root 3 is approximately 1.7, right? So we have to have this triangle memorized. And then what I do is I always draw my special triangles in quadrant 1, right? That's the only quadrant you really need to have it memorized in. So if they want 30 degrees, that's my 30, 60, 90. This special triangle across from 30 degrees goes my smallest side. My biggest side would be my 2, and this would be my root 3. Okay, so the numbers 1, 2, and root 3. So now what I'm going to do is I have to put those numbers in quadrant 3. We're in quadrant 3. And this reference angle is 30 degrees. Okay, so you have to now in quadrant 3 put your numbers 1, 2, root 3. So 1 goes across from your 30. So I'm just going to erase this now. So we have to label the special triangle in quadrant 3. Okay, so 1 goes across from your 30. Your radius is 2. And across from the 60, so this would be 60, would be your root 3. From here, let's figure out what's positive and what's negative. So my radius is always positive. What do you think about y down here? Would y be, is that 1 positive or negative? And in quadrant 3, y's are negative. So I'm going to put a negative there. And then my x value, here's my x value. In this quadrant, x's are also negative, right? So my x value would be negative 3. Okay, so how we do this is we need to just read this triangle. The sine of 210 degrees is equal to y over r. And we're just going to read the special triangle. So y is negative 1 and r is 2. So the sine of 210 degrees is negative 1 over 2. And then let's check according to our cast rule, if I'm right. So according to our cast rule, we are in quadrant 3. The only angle that is positive in this quadrant is tan, so sine is negative. Okay? So again, a lot of information there. Try B with me and then see if we'll start to click after B. Cos of 300 degrees. We need to find where that rotational angle is. So draw yourself a little Cartesian plane and let's put in cos of 300 degrees. That would be in quadrant 4, right? So my rotational angle would be this, 300 degrees. So you always, first step is draw your rotational angle. Second step is to draw your acute triangle. So that would be my acute triangle. With the acute triangle, you always calculate, well, what is that reference angle? If this is 300 degrees, one complete rotation is 360 degrees. So to figure out that reference angle, it's 360 degrees minus 300 degrees, and that reference angle would be 60 degrees. So 60 degrees. Now you have to put in your numbers 1, 2, root 3. 1, 2, root 3. So if my reference angle is 60 degrees, this guy would be 30 degrees. And across from the 30 degrees is the smallest number, which is 1. My hypotenuse, which is the radius, would be the longest side, which is 2. And this would be root 3. right? Across from 60 would be root 3. Once you get your 1, your 2, and your root 3 in, you need to figure out what's positive, what's negative. So this is my x value, and x is positive. So that 1 I'm going to keep as 1. My radius is always going to be positive, and in this quadrant, y is negative. So now the cos of 300 degrees, cos of 300 degrees, I just need to look at, it says you write it in terms of your reference angle. So this is at 300 degrees, and I just need to look at the triangle that is made with that reference angle. So cos, you know, is x over r, and at 300 degrees, x over r, so this would be my special triangle here, x is 1 and r is 2. So cos of 300 degrees is equal to 1 over 2. And let's see if we could verify that on our calculator. The cos of 300 degrees is equal to 0.5, 1 over 2. Let's do class example 3, and I'm hoping that by class example 3, it's going to click. When we do exact values, you guys, your reference angle, you'll either always get a reference angle of 30, of 45, or of 60. Those will be your only reference angles because those are your only special triangles. So I'm just going to erase all this. And let's draw a rotational angle of 225 degrees. So that's always the first thing you do, a rotational angle of 225 degrees. That's 180, this is 270. So 225 degrees would be in quadrant 3. The rotational angle would look something like this. That would be 225 degrees. But what I need is I need to figure out, okay, what special triangle is this? So draw your acute triangle. And I need to figure out what this little tiny angle is. That wasn't the greatest triangle. I need to figure out what this purple angle is, what that reference angle is. So using 225 degrees and 180 degrees, theta r would be equal to 225 minus 180. My reference angle for this question would be 45 degrees. Okay, there's my 45 degree, which is my isosceles triangle. That, remember, was the 1, 1, root 2. So the only thing you have to memorize for 45 degrees is 1, 1, root 2. So let's go into this triangle. Let's put in that 45 degree angle. So if that's 45 degrees, this guy's 45 degrees, there's 90. 45 degrees, remember that this would be side 1 and that would be side 1. Root 2 is the longest side, so root 2 would go here. So you label your special triangle 1, 1, root 2, and after you have it labeled, you could then put in your positives and negatives. So my radius is always positive. X in this quadrant is negative. So I'd have to say that that 1 is really a negative. And my y is also negative, right? So this would be the special triangle. Okay, tan of 225 degrees. You only need to look at the special triangle. Tan is y over x. Y is equal to negative 1 over x is negative 1. Tan of 225 degrees is equal to negative 1 over 1, which is positive 1. Let's check according to my cast rule. C-A-S-T. I am in quadrant 3, which is right here. And in that quadrant, tan is positive, and sure enough, tan is positive there. So the tan of 225 degrees is equal to 1. So we're going to do the same sort of thing, and we're going to do class example 2 and class example 3, and then I'll assign you your homework, and I'll give you some homework. I'll do some homework questions for you. Okay, when it says without using technology, I will allow you to use technology. Okay, what question 2 and question 3 are on? They are on finding the angles. And finding the angles, we always do the inverse button, which is that second function button. So remember from, again, you have to use information now from lesson 3. Cos of theta, they're telling me, is negative. So we always, when we're figuring out angles, start with our cast rule. And where is cosine negative? Cosine is negative in this quadrant and in this quadrant. So I'm going to have two solutions, okay, where cosine is negative. And what we have to do to find that angle, we're going to do the inverse cos of the absolute value of that number, which is just always the positive value. So let's type in on our calculators the inverse cos of the square root of 3 divided by 2. And we get 30 degrees. Okay, so from lesson 3, what did I tell you that that angle will always be? And the answer is that's your reference angle. So theta r is equal to 30 degrees. So remember that we have two solutions. One of my solutions is in quadrant 2, right? Cos is negative there. That would be my angle in standard position, but my reference angle is 30 degrees. So what do we do? Let's draw our acute triangle. And what kind of a special triangle would this be? If you got a 30-degree angle, this would be your 30, 60, 90-degree special triangle. And what you have to memorize for that is 1, 2, root 3. So if that's 30 degrees, this is 90 degrees, this is 60 degrees. Across from my 30 degree is my smallest side, which is 1. The number that's bigger between 2 and root 3 is my radius, or my hypotenuse, so that's going to be 2. And root 3 is always across from 60. Okay, and actually, I don't even know why I showed you all that, because I didn't need to do that. They just wanted to know what the angle was. So sorry, I'm not sure why I showed you that. That's how you would label your special triangle, but we don't need to. What is that angle in standard position? So the angle in standard position is your rotational angle. If this is a 30-degree reference angle, that would be 180 degrees. My angle in standard position is 180 degrees minus 30 degrees. And my first solution is 150 degrees. That's how you would label the special triangle. We didn't actually have to do all that work. I don't know why I did that. Let's draw now our angle in standard position in quadrant 3. So in quadrant 3, our angle in standard position would be right here. That's the angle in standard position. So we need to figure out what is this value here. We calculated that our reference angle is 30 degrees, right? So again, it is a 30, 60, 90 degree triangle, but what would this angle be? Well, if this is 180 degrees, what is 180 plus 30? 210 degrees. So my two answers are 150 degrees and 210 degrees. And if I wanted to check that on my calculator, let's type in, for example, the cos of 150. And let's type in the cos of 210. So the cos of 150 is that number. The cos of 210 should be the exact same number. And I'm going to say that these two numbers are going to be negative root 3 over 2. So negative root 3 divided by 2. Okay, let's do class example B. So actually no, class example B we don't need to know. Where tan is undefined, you would do that on your chart later on. Okay, let's do class example 3, which is going to be very, very similar to this. Okay, so again, it says without using technology, and I will allow you to use technology for these questions. So in the homework, when it says without using technology, I will allow you. Point P has these coordinates here, is on terminal arm of angle theta. So we know that this gives us a coordinate of x and y. So they want my x value to be at negative 3, and my y value is at root 3. So just to sort of show you on your calculator where root 3 is, remember that root 3 is approximately 1.7. So 1, 2, I'm just going to put a dot right there. Okay, and I'm going to say that that point is at negative 3 root 3. So let's draw our terminal arm. So remember, use a ruler. The point that they give you, it always lies on the terminal arm of the rotational angle. So this is my rotational angle. This is point P, and they are saying that the x coordinate is negative 3 and the y coordinate is at root 3. So let's write that, x and y. Let's draw our triangle. So we always draw our triangle. And we're going to have to figure out probably what our reference angle is. So let's label x and y on here. Okay, so x is negative 3. Y is root 3. And I don't know what r is, what the radius is. If they want me to, I will have to figure that out using Pythagoras theorem, but we'll see if they want that. A, draw the angle in standard position. So this pink angle would be my angle in standard position, and I'm going to call that theta. That's my angle in standard position. This angle within the triangle would be my reference angle. So A says draw the angle in standard position and mark the point P. We've done that on the terminal arm. A is done. B, state the values of x and y. So I've done that on here. X is negative 3. So I'll write it down for them. X is negative 3. Y is root 3. They don't actually ask for r, right? I could do r using Pythagoras theorem, but they're not asking for that. So they're just saying write the value of x, done. Write the value of y, done. And then write the value of tan of theta. Okay, so tan of theta is equal to, we know that tan is y over x, and I do have what y is, and I do have what x is. So tan of theta is root 3 over negative 3. And that would be my tan of theta. Let's check according to our cast rule. We are in quadrant 2. And the only angle that's positive in quadrant 2 is sine. Sure enough, tan is negative. Okay? Then what it says is it says state the reference angle and the rotation angle of theta. So we're going to use this information in order to do that. So the tan of theta, we got root 3 over negative 3. So if I said, well, what is the angle? Remember, in order to calculate angle, that's an inverse function. So in order to calculate the what theta is, we would take the inverse tan of the absolute value of this number. And the absolute value, we haven't done that unit yet, but the absolute value is just this number, the positive value of this number. So that would be root 3 over 3. So let's figure out what that is on our calculator. So second function tan of root 3 divided by 3, and we get 30 degrees. What did I always tell you when you do the inverse of a function? That always gives you your reference angle. So if I was to go back and I was to draw that picture, my angle in standard position was this, and my reference angle is 30 degrees. So question C says state the reference angle. I've calculated it, so let's do that. The reference angle is 30 degrees, and we'll box that in. And what would the rotational angle be? So if this is the reference angle, the rotational angle is from 0 to my terminal arm. So this is 180 degrees, and I'm going to subtract 30 degrees, and I will get a rotational angle of 150 degrees. Okay. The homework questions that I want you to do, number 1, you should already be done. That's your chart with your special triangles. I want you to do these questions from number 2. And I'm actually going to set up 3, 4, and 5 with you. The book says do not use technology for these questions, but you can use technology because we're doing the inverse, right? So you'd use technology. Okay, so question 3. Let's have a look at this. So without using technology, determine the exact values. And actually, before we do that, let me just maybe do, question 2, no. These are your special triangles, you guys. You're going to ignore, like when you look in your solutions, this. And for example, if I'll do A with you, and then I'll do question 3. Okay, cos of 120 degrees. Find the exact value. That means special triangle. Actually, you know what? I'll do B. B is tan of 300. Okay, so where would the rotational angle of 300 degrees be? So 300 degrees, 180, 270, 360. So 300 degrees would be in the 4th quadrant. From here, maybe I'll write that a bit nicer. 300 degrees. Okay, you always draw your special triangle. So from your terminal arm, go up to your x-axis. And once you have your special triangle or your acute triangle, you figure out what that reference angle is. So the reference angle is 60 degrees minus 300 degrees. And I hope you see that that reference angle would be 60 degrees. If we have a 60-degree reference angle, what special triangle are they talking about? And they would be talking about the 30, 60, 90. Label your special triangle 1, 2, root 3. Across from your smallest side, which is 30, goes your smallest number, which is 1. Between 2 and 1.7, 2 is bigger, so that goes on your radius. And root 3 is always across from your 60 degrees. Once you have your special triangle labeled, then put in your positives and negatives. So x, this is x, and x is positive 1. My radius is always going to be positive. This is my y value, and in this quadrant, y is negative. So the tan of 300 degrees is equal to tan is y over x. Y is negative root 3 over x, which is 1. And that would be negative root 3, right? If I was to do another one, let's do j really quickly together. So j, so again, ignore this stuff. Cos of 210 degrees. Always draw your rotational angle. 210 degrees would be in quadrant 3. Rotational angle, that's step 1. What was step 2? Acute triangle. That's step 2. Step 3, let's figure out what our reference angle is. So our reference angle, just going to erase this. Our reference angle is 210 degrees minus 180. So what was 210 minus 180? That would give us a reference angle of 30 degrees. So this would again be the 30, 60, 90 degree triangle. So from here, let's put in our 1, 2, and our root 3. So the 1 goes across from the 30. The 2 is my biggest side, that goes across from the 90. And the root 3 is always across from the 60. Let's label. My x in this would be negative. My y is also negative in quadrant 3. My radius is always positive. Cos of 210 degrees, cos is x over r. X is negative root 3. That should be root 3. Negative root 3 over r, which is 2. And that would be the exact value, negative root 3 over 2. Okay, so I want you to do these ones here. And actually the ones that I want you to do, just looking at it, I'll tell you right now. So I might change it slightly. A, B, C, D, E. You can pretty much, I guess the ones, oh, this guy, no, no, no. This is a good one. J, this guy. So do all of those. Okay, question number 3. I will do one of these for you. I'll do A. And you'll do B and C. And please omit D. So we're finding the angle. And sine is positive. So according to my cast rule, sine is positive in its own quadrant and in quadrant 1. So I'm going to have 2 solutions. Finding an angle, we do the inverse sine of root 2 over 2. So inverse second function sine of root 2 divided by 2, 45 degrees. Remember, this always gives us our reference angle. I have 2 answers. One of my answers, they want the rotational angle in quadrant 1 if this is 45 degrees. And remember that in quadrant 1, your reference angle is equal to your rotational angle. So that rotational angle will also be 45 degrees. So one of my solutions is 45 degrees. My other solution is in quadrant 2. Reference angle is 45 degrees. So remember, you always draw your triangle. And they want the rotational angle. This from 0 would be the rotational angle. So in order to get that rotational angle, 180 degrees minus 45 degrees would give you a rotational angle of 135 degrees. And that would be your two answers. So I want you guys to try B, and I want you to try C. For number 4, the point is on the terminal arm of angle theta, so xy. So let's find out where that point is. Y, x. I'm not even going to calculate what the negative square root of 2 is and what the negative square root of 6 is. You should be able to see that negative x would be here, and negative y is down here. So my point would be somewhere in quadrant 3. Okay, and I'm going to say x is equal to negative root 2. Let's draw using our ruler, let's draw our point on our terminal arm. Let's label our point. So for these questions, we always draw our point, and we always label our point. They want x to be negative root 2, y to be negative root 6. From there, always draw your triangle. So vertical line up to your x-axis. Now let's label our triangle. X is negative root 2. Here's my y, and my y is negative root 6. A, draw the angle in standard position. Okay, so I have to show that. So from 0, it would go to my terminal arm. That is theta, and that's my angle in standard position. They're probably going to ask me to calculate, well, what is that angle, right? I know it's going to be greater than 180, less than 270. So draw the angle in standard position and mark the point on the terminal arm. Done. This would be A. B, state the values of x and y. Okay, x is equal to negative root 2, y is equal to negative root 6, and hence we could do the values of tan of theta. Tan of theta is y over x. Y is negative root 6 over negative root 2, and that would be the tan of theta. Now, a couple things we have to remember from our radicals unit. So 2 negatives give me a positive. So that would be root 6 over root 2. And you guys, from radicals, what is root 6 divided by root 2? Remember, that's the same thing if you have the same index. That's 6 divided by 2, which is root 3. So the tan of theta is root 3. So it's taking trig, everything you learn from trig, and then it's also taking something from radicals, like do you remember that these two would be divided? Let's check according to our cast rule. Is tan, I get that tan is positive in this quadrant. So let's double check according to cast. We are in quadrant 3, and yes, tan is positive. Okay, state the reference angle and hence the rotational angle. So we need to use this answer. So tan of theta is equal to root 3. We are figuring out an angle, so we are doing an inverse function. So the inverse tan of root 3 is equal to 60 degrees. So remember, whenever we do an inverse function, that always gives us the reference angle. Okay, so we just did the reference angle. Now they want the rotational angle. So this reference angle was 60. What was this red angle? From 0 to 180 plus 60, right? So our rotational angle is 180 degrees plus 60 degrees. And if you add 180 plus 60 degrees, you will get a rotational angle of 240 degrees. So for C, theta theta is equal to 240 degrees. 5 is going to be very, very similar, right? So our last question will be very similar. The point 5, -5 is on the terminal arm of angle A. So if x is 5 and y is -5, there's my point. Let's use our ruler and let's draw the terminal arm. So from your origin, let's do what we always do. Let's label that point. X is 5, y is -5. Let's draw our triangle. Let's label our sides. Looks like they don't want me to calculate radius as of yet, but we could using Pythagorean's theorem. Okay, point 5, -5 is on the terminal arm of angle A. Determine the value of angle A. So the other two questions, question 3 and 4, or especially question 4, we did it in steps, right? So we can't quite do this in steps. So we know what we're going to do is we're going to figure out what the tan of theta is. And the reason why we use the tan of theta is because tan is y over x, and we have on our triangle, they gave us y and they gave us x. So the tan of theta is equal to y, which is -5, over x, which is 5. So tan of theta is -5 over 5. Let's figure out what theta is, and that gives us our reference angle. So the inverse tan of the absolute value. And actually what I could do is -5 over 5 is the same thing as -1. So let's actually just write that. I could put like 5 over 5 here. You'll get the exact same answer. But it's the inverse tan of -1. And remember, we always type in the absolute value or the positive value. So we're going to figure out what the inverse tan of 1 is. So second function tan of 1, 45 degrees. That always gives you your reference angle. If this is 45 degrees, the question is asking, what is the rotational angle? One rotation around the circle is 360 degrees. So my rotational angle is 360 degrees minus that reference angle of 45 degrees, and I would get 315 degrees. So my theta in standard position, or my rotational angle, is 315 degrees. And that's how you would do this question.